Hello friends, so here is another question on specific heat, latent heat and the concept of heat loss and heat gain. So it is given that a thermally insulated vessel contains 100 grams of water at 0 degrees Celsius. Then air above the water is pumped out. As a result of it, some of the water it freezes and some evaporates at 0 degrees Celsius itself. Calculate the mass of ice formed in the vessel if no water is left. So some information is given. Latent heat of vaporization of water at 0 degrees Celsius is 2.1 into 10 to the power 6 joule per kg, and latent heat of fusion of ice, that is 3.36 into 10 to the power 5 joule per kg. So here the concept is based on latent heat, because when we think about evaporation, condensation, freezing, melting, everything happens at latent heat. Okay, evaporation, condensation, it happens at latent heat of vaporization, and freezing, melting, it happens at latent of fusion. So I have discussed it in detail in the video related to latent heat. So please watch all the videos before watching these numerical videos. I request you to please go through all the theoretical concepts video once again. If you have watched it, then better it's to just revise all of that concepts again. And if you have not watched those theoretical concept videos, then please watch those videos first, then go for these numericals. Okay, so here the data which is given is that here in this vessel there is initially water present. Okay, so the mass of water which is present initially is 100 grams. So the condition is that air above the water is pumped out. Okay, air is pumped out, as a result of which some portion of this water it evaporated and some freezed, okay, to form ice. So water vapor evaporated and some ice is formed. So we have to find how much mass of ice is formed and what is the mass of vapor. So we have to calculate this. If we calculate the mass of ice which is formed, we can get the value of mass of vapor also. So out of this 100 grams, let's say the mass of ice which is formed is m grams. So no water is left in the vessel, so the remaining mass of water is converted into vapor. Okay, so the mass of vapor which is formed is 100 minus m grams, so it is in grams. The data which is given related to latent heat, it is in kg, so we have to convert it into grams. So here it is given that the latent heat of vaporization at 0 degrees Celsius is 2.1 into 10 to the power 6 joule per kg. So it is equal to 2.1 into 10 to the power 3 joule per grams. 1 kg is 1000 grams, so we get 2.1 into 10 to the power 3 joule per gram. Okay, then the latent heat of fusion at obviously at 0 degrees Celsius, latent of fusion of ice, that is equal to 3.36 into 10 to the power 5 joule per kg. So it will be equal to 3.36 into 10 to the power 2 joule per grams. So we'll be using this data, the gram data, because we have taken the mass of ice and the mass of vapor in terms of grams. Okay. So now here the situation is that for this entire thing to happen, the heat gained by the portion of water which evaporated, okay, the heat gained by 100 minus m gram of water in evaporation is equal to the heat lost by m grams of water which turned into ice in freezing. This is the condition. Okay, this is the condition. Because heat gain is always equal to heat loss. That is the basic principle of calorimetry. So the heat gained by 100 minus m gram of water in evaporation, which converted into water vapor, is equal to, okay, the heat gain is equal to mass of vapor into latent heat of vaporization, and the heat loss by water which turned into ice in freezing, that is equal to the mass of ice which is formed and the latent heat of fusion. So this is equal to 100 minus m into latent heat of vaporization, which is equal to 2.1 into 10 to the power 3 joule per gram. And this is equal to m, which is the mass of ice form, m grams, into how much? 3.36 into 10 to the power 2 joule per gram. That is the latent heat of fusion. So according to the principle of calorimetry, Q gain, the heat gain, is equal to heat loss. So if we equate these two, we get (100 minus m into 2.1 into 10 to the power 3 is equal to m to 3.36 into 10 to the power 10 to the power 2. Okay, that implies 2.1 into 10. Okay, 2.1 into 10 to the power 5. Okay, 2.1 into 10 to the power 5 minus 2.1 into 10 to the power 3 m is equal to 3.36 into 10 to the power 2 m. That implies, if we take this minus to the other side, we get 3.36 into 10 to the power 2 plus 2.1 into 10 to the power 3 m, because m is common in both of them. That is equal to 2.1 into 10 to the power 5. That implies m is equal to 2.1 into 10 to the power 5 by 3.36 into 10 to the power 2 plus 2.1 into 10 to the power 3. So it is coming around 86.2 grams, okay, m, which is the mass of ice formed, okay. This is the mass of ice formed. So the mass of water which vaporized, which is 100 minus m, which is equal to 100 minus 86.2, which is equal to how much? 100 minus 8, 14 minus 13.8 grams. Okay, 13.8 grams it turned into water vapor. So this is the basic concept. The previous questions which we discussed, it was on specific heat. So this is based on latent heat of fusion and vaporization. So here the basic principle to understand is this, that when this whole process took place, this is the general thing, the general operating principle. The heat gained by the mass of water which vaporized is equal to the heat lost by the mass of water which turned into ice. This is the thing, because when something gains heat, it evaporates, from this thing, and when someone loses heat, its temperature is lowered. So obviously, as per this the condition laid out in this question, it converted into ice, it freeze. Okay, so this is the general concept. So here is another question on specific heat. It is given that a normal diet furnishes 2000 kilocalorie to a 60 kg person in a day. If this energy is used to heat the person, that is to increase the temperature of the person, with no external losses to the surroundings, it means the entire energy is used by the body with no loss, how much would the person's body temperature increase? Okay, so here this question is based on this concept. Okay, Q is equal to mc delta T, where Q is heat loss or gain. Here it is gain, because the entire energy is gained by the human body. Okay, so here it is heat gain, or the energy which is used up. Then C is the specific heat of the body, which according to the question is given 0.83 calorie per gram per degree Celsius. This is heat energy given to the body. Then the mass of the human body, that is 60 kg, which is equal to 60 into 10 to the power 3 grams. Okay, because everything is in grams, so it should be better that we convert it into gram. And then the increase in temperature, which we have to calculate. So simply delta T is equal to Q by mc, which is equal to, this Q is given as 2000 kilocalorie, which is 2000 into 10 to the power 3 calorie. Okay, so it is equal to 1000 into 10 to the power 3. Mass is equal to 60 into 10 to the power 3 into specific heat, which is equal to 0.83. So it is coming around 40.16 degree Celsius. This is the increase in temperature of the body. If 2000 kilocalorie of energy is used up to heat the person with no external loss. Okay, so this is it.